about the gases that first became possible in 19th century led John Dalton in 1803 to propose the modern theory of an atom. But his works doesn't end with that. John Dalton was the first to recognize that the total pressure of a mixture of gases is the sum of the contributions of the individual components of the mixture. By convention, the part of the total pressure of a mixture that results from one component is called the partial pressure of that component. Dalton's law of partial pressures states that the total pressure of a mixture of gases is the sum of the partial pressures of the various components. John Dalton derived the law of partial pressures from his work on the amount of water vapor that could be absorbed by air at different temperatures. It is therefore fitting that this law is used most often to correct for the amount of water vapor picked up when a gas is collected by displacing water.
States that the total pressure of a mixture of gases is equal to the sum of the partial pressure of the component gases. And this is the general formula to be used.
Suppose that we have three different containers with different gases, namely the nitrogen gas, which had 75 mm mercury as a partial pressure, the hydrogen gas, which had a partial pressure of 50 mm mercury, and lastly, the oxygen, which had the partial pressure of 100 mm mercury.
After determining the partial pressure of each gases, the next thing will be finding the total pressure of three gases.
At constant temperature, the pressure exerted by a mixture of two or more non-reacting gases enclosed in a definite volume is equal to the sum of the individual pressures which each gases would exert if present alone in the same volume. And this is the representation of the total pressure of the three gases, which is the nitrogen, hydrogen, and oxygen. 75 mm mercury of nitrogen plus 50 mm mercury of hydrogen plus 100 mm mercury of oxygen is equals to 225 mm mercury.
This is the simplest example that we can show regarding the Dalton's law of partial pressure. But remember that there is a formula that deals with this same law that is dependent with the temperature, the volume, and of course, the pressure.
This is the group 4. Thank you for watching.
See you and goodbye!
Yay!